for all x belongs to R, y greater than 0. Show that there exists a comma b belongs to R such that fx is equal to ax plus b for all x belongs to R. That means we have to prove that fx would be a linear function. Now, they have given f to be twice differentiable function. So we are very much free to differentiate it using Newton-Leibniz formula. So if I differentiate both sides with respect to x, differentiation with respect to x. So y will be considered as a constant. Here you can see x belongs to R and y is some positive integer which is independent of x, because we are not given any relation of x with y, so we can assume that it is independent from x. So if I do the differentiation with respect to x, we will be getting 1 upon 2y. Then differentiation of upper limit, that is 1, and this upper limit will be going in place of t, so this will be x plus y here, minus differentiation of lower limit, that is also 1, and then in place of t I will be putting x minus y here, and that is equal to f dash x. Okay, now we can do it by graph also, but I think the better approach I'm thinking of doing this question is that I can write this as f of x plus y minus f of x minus y is equal to 2y into f dash x. Now, as y can also be considered to be a variable, keeping x fixed at some number and varying y, I think I can do the differentiation with respect to y also. Differentiating with respect to y, now what we will be getting, f dash x plus y, and now it will be plus f dash x minus y, and on the right hand side it will be 2 f dash x. Okay, so one interesting thing what we are getting here is that this f dash x, that is derivative at any x, is always the mean of derivative of the function at x plus y or x minus y. The same thing could have been seen from this relation also. Here what you could have said that f dash x is actually equal to the slope of the chord joining x minus y to x plus y. You can see, you can define like this, that my x coordinate is x minus y coordinate is, let us say, f of x minus y. That is one point, and another point you can take as x plus y comma f of x plus y. So if you join these 2 points and take their slope, I think this left hand side will be the slope. So this chord joining these kind of 2 points having slope same as f dash x. So whatever y you choose, that means x is so located that if you take differentiation, it will be equal to the slope of a chord joining 2 points, and these 2 points are such that they are equally spaced about x, one at x minus y, one at x plus y. And I think such is a property of parabola also. If you differentiate and if you take if you have done the question of Rolle's theorem, or I think Lagrange's mean value theorem, you will find that for any 2 point on the parabola, the C of that Lagrange's mean value theorem comes exactly at the midpoint. So this gives you the feel of that it could be a parabola, but I think that I'll get in another way also. Please see how, if I differentiate this once again with respect to y, it will become f double dash x plus y minus f double dash x minus y is equal to 0. What exactly this says, because x I can choose anything, okay, then x plus y and x minus y are kind of, two arbitrary numbers. You can take x plus y as t, okay, then this f double dash t here will become equal to f double dash, I can write y as t minus x, and y as t minus x means it will be 2x minus t. So I am free to choose any value of x. That means my second derivative has to be constant, because it has to be true for all t and all x. Okay, so what we have concluded so far, that its second derivative will be constant, and in fact the same thing I was saying from this thing also, that it would be a parabola, and you know that in parabola second derivative is a constant value. Okay, let me take another slide. So to do the further part of this question, let us take this new slide, and here, because we have proved that f double dash x is a constant, and you know that f double dash x constant means it has to be second degree polynomial. So fx can be taken as px square plus qx plus r. So only thing we need to prove here is that p will become 0. Now to do this thing, we will use this relation once again. How? Please see, 1 upon 2y into, I think integration of this thing can be written directly. I just need to change this x by t first, and then doing the differentiation, it will become p t cube by 3, then q t square by 2 plus rt, and this limit is x minus y to x plus y, and this has to be equal to fx. That means it will be px square plus qx plus r. Now let us put the limits. So this will be 2y here, p by 3 into this t cube. I will be first putting x plus y whole cube, then I will be putting x minus y whole cube and taking the difference of these two. And similarly, q by 2 t square, it will be x plus y whole square first, minus x minus y whole square then, and then r into x plus y minus x minus y, and this has to be equal to px square plus qx plus r. Now please see how much, what will be the things we will be getting after simplification. 1 upon 2y here, and p by 3 into x cube will get cancelled. Okay, I think the another term will be 3x square y, and here it will be getting added because there will be 2 minus minus, so plus. So here we will get 6x square y, and I think then 2y cube also. Okay, then for this q by 2 into this thing, x square plus y square term will get cancelled. This will be 4xy, so I can write this as 2q into xy, and here I think it is just 2ry, and this we need to be equal to px square plus qx plus r. Okay, if we divide by 2y inside it, what we will be getting, I think this will be 2y will be cancelling it like p by 3 into 3x square plus y square only, then plus 2q xy, I think this will remain only qx, and here only r, and this should be equal to px square plus qx plus r. So you can see both sides to be exactly identical. Okay, I think qx rx we are already getting, but here to make it identically equal, I think we need to have p is equal to 0, because y is positive, you cannot have these things to be equal. Okay, so p, if it is 0, that means my fx is actually a qx plus r form, or you can say ax plus b form, that is linear. So I think this completes the solution of this question. Okay, now coming